Okay, this is the mock paper 1 question 6 to probably about 9. We've got this question here. Write x squared plus 2x minus 8 in the form x plus m all squared plus n, where m and n are integers. This is exactly the way that you'll usually get shown an algebraic expression that you're wanting, that the question papers want you to write in completing the square form, or completed the square. So this here is complete the square form. So you have to remember how to write something by completing the square, and the key there is to halve the coefficient of x. So that's going to give me 1. And that's what goes with your x inside the bracket. So instead of, we're going to halve that coefficient of x to be 1, and that means we're going to have x plus 1 all squared. Now it probably seems a bit confusing where all that comes from, and as we're just going through the paper, I'm not going to spend a great deal of time going through it, but what you might want to do is just pause the video and expand this out. What you'll do, maybe pause the video now and have a go at that. Pause this and expand this out if you're not sure about this topic. Okay, hopefully you've now clicked play, and you'll have got x squared plus 2x plus 1. And so we've got a plus 1 there, which we don't really want, because we're just wanting this x plus 1 all squared to represent the x squared plus 2x, so I need to subtract 1 after this. And then at the end I've got to remember I've got that minus 8 too, so I need to subtract 8 from that. And what does this mean? That means I've got x plus 1 all squared minus 1 minus 8, but that's minus 9. So this is a fine way to leave your answer, but we could have stated therefore that our m is equal to 1 and our n is equal to minus 9, but that's perfectly fine. X plus 1 squared minus 9, and we've completed the square. Next is a classic construction where we're asked to construct the perpendicular bisector of AB. Perpendicular we know is right angles, that's what perpendicular means, and bisector is when two things are cut exactly in half. Okay, so not just cut, but cut in half. So a line that's been bisected would be cut into two equally sized sections. So the perpendicular bisector is going to do both of those things, and we can achieve that by getting a compass and placing the nib at one end and then the pencil bit at the other end, so they're both the same length. Now actually this would work even if we were about 3/4 of the way along the line, but I would say do the whole length of the line if you possibly can, as that means if your compass slips then you can just move it back to just double checking it's the same length as the line to avoid any mistakes. Sometimes the question might mean that you've not got enough space to do that, but the vast majority of the time you'll get away with it. So we've done that. From one side I've drawn an arc from A through B like that, so I believe that was actually 1 mark in the mark scheme, and then we get our compass again, and this is the advantage of having the arcs the same length as the line, because I can just double check my compass hasn't slipped. Fortunately it hasn't, so I can draw another arc, and where these two lines intersect is where I get my ruler, I get my pencil, and I draw my line through this point down to this point here. And you'll see that not only is this line perpendicular, but it's also bisecting this line segment AB. Question 8. Question 8 is asking us to prove, so we're going to have to be really careful that we're very clear in this, even though it's just 2 marks, algebraically that the recurring decimal 0.25 recurring has the value of 23/90. So whenever you've got a recurring decimal problem and you're going from the decimal to the fraction, you need to start by writing out the decimal. So the decimal, if I call that decimal x, is 0.25 recurring, and instead of writing 25 with a dot above it, I'm going to write what that dot above the 5 means. So that means I've got 0.25, 5, 5, 5, 5, 5, 5, and so on. Now if you have 1 digit recurring, that's when you're going to multiply this now by 10. If there were 2 digits recurring, then I'd multiply it by 100, 3 digits, 1,000, etc. But 1 digit you multiply by 10, and we'll see why. So if I multiply this by 10, Try and keep everything lined up, so keep your decimal point lined up too, and we're going to get 2 points. What's it going to be? 5, 5, 5, 5, etc. recurring. Now the advantage of this is that this recurring 5s situation has been solved to a state that we can now get rid of the recurring bit, because I've got the 5 recurring here, 5, 5, 5, 5, 5. I've got the 5 recurring here, 5, 5, 5, 5, 5. So if I subtract one from the other, I'm going to get rid of those recurring 5s. So if I do my 10x minus 1x to leave me with 9x's, that's going to give me 2 minus 0, which is 2. 0.5 minus 0.2, which is 0.3. 0.05 minus 0.05, which is 0. 0.005 minus 0.005, which is 0. So I've got rid of all those 5 recurring sections. I'm just left with 9x equaling 2.3. So let's make x a subject. That means x is equal to 2.3 over 9. But of course, if we're leaving this as a fraction, then we need to get rid of the decimal component of that. So I can say that it's 23 over 90. Now I believe in the mark scheme that you get 2 marks for this. However, the fact that it says prove there is going to mean I'm really going to encourage you, whenever you see the prove, to just sort of conclude with what you've found. So that is literally stating what the question has asked you to do. So hence, what's the question asked me to do? Prove algebraically that the recurring decimal 0.25 recurring has the value 23 over 90. So hence 0.25 recurring is equal to 23 over 90. Okay, we've proven that algebraically. We've applied the algebraic value x, worked our way through to show that that was the case. Try whenever you're proving to just conclude with what you've done. And we're on to question 9. We've got a grouped frequency table about the times and minutes that 80 office workers take to get to work. We've got the times here and the frequency here. And we're asked to make the cumulative frequency. So you were immediately stuck if you couldn't remember what cumulative frequency is, but there's kind of a clue in the table itself. We have a look at it. In that we've got 0 to 20 here and 0 to 20 here. Oh, so far so good. But here we've got, instead of 20 to 40, we've got 0 to 40. So this means we've got all the times from 0 to 40. So this kind of makes up for the fact that these are 2 separate tables. You might more often be used to having time frequency and the cumulative frequency as an extra column here. So all we need to do for our mark is just to add these up. So between 0 and 20 we just have 5 like before, but between 0 and 40 I've got that 5 plus that 30, so 35, and so on. So I'm going to get 55, then adding on my 15, now 70, adding on my 8, 78, and then finishing with 80. And I was told there were 80 office workers, so it's encouraging that I've finished with 80 there. Always look for little things in the questions that might just reassure you that you've not made a silly mistake when you're adding things together. Okay, so we've filled in the cumulative frequency chart table, and now we need to plot it as a graph. Now the one thing to remember for cumulative frequency and plotting them, really, is that unlike some graphs, such as frequency polygons, we're going to plot this at the upper bound. So that means that my cumulative frequency of 5, I'm going to plot at 20. So at 20, I'm going to go up by 5. At my value of 40, I'm going to go to 35. I'm not doing this at the midpoint, like I would do with some graphs, like a frequency polygon. I'm doing it at the upper bound. So I'm plotting at 20, 40, 60 for all of these. So if we finish that off, we've got 60, 55. Not the best graph to work on. 80, 70. Right there. 100, 78. And 120, 80. Okay, and we typically should see in a cumulative frequency graph a rough S shape. I know this isn't a perfect S, but certainly if we include like the 0, 0 point, which you didn't need to include for all the marks for this question, then we have got a rough S shape here. And again, I would just use the curve of your hand when joining these points together. We did need to join these together to complete our graph. So that's our cumulative frequency graph. Could have done it a little bit neater, but we've got there. Final bit, we use your graph to find an estimate of the percentage of these office workers who take more than 90 minutes to get to work. Well, let's find the time in minutes, and let's find 90, that's going to be there. Firstly, we need to evidence that we're using that 90 minutes, so we'll go from our 90 up, and we're going to go across. Right, so working across from this, then I would make this 70, 1, 2, 3, 4, 5. So it's about 74. I'd actually say that was about 75 from my graph. The mark scheme did allow you to, using your own graph, it allowed that there's going to be a bit of discrepancy there, so maybe you got 74. That means, if we think about this, the time to get to work up to 90 minutes, we've got 75 members of staff by that point. So this remaining section here of 5 people, my 80 minus 75, that's what's left to calculate a percentage of. So if I'm trying to find the percentage who take more than 90, that's this section here, that's represented by 5 people. So I've got 5 out of 80 people, and I need to try and deduce what that is without a calculator as a percentage. So I could perhaps try and think about the fact that this is 5/8 times a 10. I know that 1/8 is 0.125. 5/8 therefore is 0.625. So if I've got my 5/8 times a 10th, I've got my 0.625 times a 10th, so 0.0625 as a decimal is my 5/80ths. And so what's that as a percentage? That would be 6.25%. For this particular section, this is only reliant on the fact that from my graph there was a gap of 5 there. If you got a gap of 4 or a gap of 6, you would have had a slightly different percentage. But generally speaking, you should have had percentages, if we look at the mark scheme, roughly linking to this. So as you see, I got 75, so 6.25%, but the mark scheme allowed for between 72 and 76, as you can see there. It's a bit of a follow through from your mark to give you those points there. So even if your cumulative frequency graph was off, it was still possible to get all 3 of these marks if you'd correctly followed that. Just make sure you're being clear of what you've done, including showing these lines that you've gone up and gone across. Question 10, and then I think we'll stop this one and start a new one. Describe fully the single transformation. So we can't describe this in more than one transformation, we have to spot one which will map P onto Q. So P to Q means we're going from here to here. It seems like the orientation, the way that this triangle is pointing, has changed. So that's not going to be the result of a translation, which would just be moving the shape but keeping it in the same orientation. Possibly it's a reflection, but it doesn't look like any obvious reflection to me. The most easy transformation to spot for this, if you like, is that it's a rotation. So this was a rotation. And when we're describing rotations, we have to describe the direction of the rotation, which we could just write down. We don't have to write down the direction. We need to write down the size of the rotation in degrees, and we also need to describe the center of rotation. So this is a rotation, perhaps you can see, of 90 degrees, and the direction is anti-clockwise, which I've not left myself enough space to write. And the centre of rotation, which is perhaps the most difficult of all of those to spot, was 0, -1. Now, if you got, I think it was 2 of those, yes, so if you got 2 of these with no others, so not if you'd also stated a translation, but 2 of rotation, anti-clockwise, 90 degrees, or centre of rotation, then you did get 1 mark. But for both of those marks, you needed all 4 of those pieces of information, as all 4 of those are required in order for us to get from P to Q. Okay. I'll stop the video there and then we'll start on question 11 in a moment.